So the next important part of the preparation for the CSWA is going to be learning how to do proper assemblies. The first one is that one with the chain. It looks like a chain, and let me bring that up so we can see it. So it is this guy, right? And all of the parts you need for this are in Schoology. So if you go to Courses, your period, under SolidWorks Practice Exam, you'll be able to find the assembly parts that you need to download onto your PC. Once you have these downloaded, then you'll be able to start the assembly. So obviously I have them already, and I can go ahead and start inserting components. Let me see if I have them all in here. There we go. So I have, bear with me, let me open this up. The chain link, the long pin, and the short pin. And it's really all we're talking about is we have a long pin, short pin, and the chain link, right? So we're going to go ahead and open all those up. That's the first, second one, and the third one, right? From here, we're going to be able to bring in multiple copies a little bit later. If we want to make changes to that, etc., we can do that individually to each one. But let's start off by assembling this part in as close to the picture as possible before we really start anything else. Okay, so we're go ahead and I've got my long pin, and remember that if I want to move this guy, once I select it, I can go ahead and rotate it if it lets me rotate it. So bear with me a second here. So it looks like I need to make it float. So float is the ability for you to be able to move it, right? So we have this here now. The first thing we're going to do is we're going to set a concentric mate. We can click on that guy, go to mate, and then click on any of the circular part up here, and we have got a concentric mate, which is that one right there. Okay. So we click OK, and I can move the part up and down. The next thing that I could do is I can go ahead and lock this top surface to this top surface. All right, and I click OK. And now those are locked in that way. So we'll stop the mates here for now and move this over to the left. And I can try and rotate this a little bit. Like I said, we're trying to get to the point where it looks kind of like the picture. Okay, so we got that there. I'm going to move this pin somewhere else right now. I'm going to move this over to the side. And then I'll go and bring in some of the other links, so some of the other parts. I've got a total of 1, 2, 3, 4 links. I need 2 more short pins, and I need 1 more long pin. So I can go to Insert Component. I need 1 more long pin, and I'll bring in these 3 all at once like that. And but it looks like I'm going to need another short pin. So I need another short pin. And then need another chain link. And we're going to need actually 1, 2, 3. So we need 1 more chain link. So we'll go 1 more and open that guy up and set it. Okay, so I've got all the parts here now. So we'll start with the last one that I brought in. I can rotate it and start kind of moving them around and match it to our assembly. Now from here, remember there's a difference between rotate and move. Once I've got it close, I'm going to take advantage of the concentric mate. So click mate, select this and select this, and they are now concentric. Now they're not locked in yet, but they are concentric. If I wanted to be locked in, what I could do is I can then select that face and select that face, and they are locked in place. So I can still move it up and down, and you'll see this. Let me click on move component. Looks like I kind of locked it up. Let's go to float again. Looks like I might have locked it in place. So let's go ahead. Let's delete this mate in here and go back to move component. And it looks like I can still move this. What I'm going to do is, since everything is moving, is I can fix certain things, right? So let me move this to the point where I kind of like it, and rotate that a little bit more. That kind of looks good right there. And I'm going to go ahead and fix this. So that's locked in place. Now when I go to move a component, this guy will move, and so will this other one, right? Now remember that they are in a concentric, so the circles are meant to match right now, but that's it. So let me go ahead and go back to and mate this with this surface, and I'm going to click OK. And now when I go to move, let me reorient everything the way I want it to. Now when I click on this guy and I go to move component, it'll just go up and down because it is locked in place two different spots, right? Okay, so now let's take this pin and I'm going to rotate it a little bit. And then I'm going to mate it. Once again, I'm going to use a concentric cylindrical mate. I select that, and I select that, and it brings it in. Now I want this face to be lined up with this face, and we are in place, right? So that takes care of the initial portion of it. So what I'd like for you to do is do the same thing for all of the other parts, and then we'll come back in just a little bit and worry about these angle mates, A, B, C, etc. All right, so go ahead and get the rest of the parts assembled together, and we'll come back in a little bit on part 2. So if you're not able to get to this point here, ask for help. Because this, just getting to this point is basic assembly techniques. Nothing is technically locked. So if I click on move for any of these things, they will move. The only thing that is fixed in place is this one on the left, just kind of to get us started, right? So the first thing we want to do is set up these A, B, and C angles, right? So they give us that A is 25 degrees, B is 125, and C is 130. Now, what shows up as 25, 30, etc., it depends on where you take your measurements from. So you have to use a little bit of common sense, right? So let's first take a look at A. A is the angle between this face and this face. So when we go to mate something, or if I select that face and then I select what kind of mate am I going to do? I'm going to do an angle mate, right? And then I'm going to select this face. So now 30 degrees brings everything all the way over. So I'm thinking that maybe I want to do not 30 degrees, but 180 plus 30, which gives us 210. And that makes more sense, right? So it's like, okay, well, it is not 210, which would be 180 plus 30, but 180 minus 30. So that would make it 150 degrees, which is looks more like what we want. So pay close attention to that. All right, so now we have A. Now B is going to be this in here, between this one and this one. So how do I go and mate these? Oops, it looks like it wanted to do a mate. So I'm going to go ahead and select one, click mate. Once again, we're going to do an angle mate. And this time, once again, if I click 30, that's not going to work. So let's do, oh, actually that's not what we want. We want 100, B was supposed to be 125, right? So let's put in 125. And in this case, that is almost exactly, that is exactly what we want, right? All right, so we're going to click OK on this one, and we've got one more to do, and it's going to be C, which is that guy. And we're also going to do an angle mate to this and to this. Now, right now it says 30. Let's put in 130, and we are good to go. That looks like all of our mates are proper. So if I align it, try and make it look like what the picture does, it looks pretty darn good, right? So now the thing is to keep in mind is it asks, what is the center of mass? So now that we've done this, we need to figure our center of mass, and that's next. So let's check what our center of mass is. And I know right now for the time being that it will be wrong, and I'll show you why in a second. But if I go to mass properties and go to center of mass, we have X. This is millimeters, by the way, so you have to make sure that your units are in millimeters. 49.5, 168, and 271, none of which are anywhere close to what the possible answers are in the multiple choice. So why not? The problem is that we currently have our coordinate system, what is called the default, and the default is this one right here at the bottom. And if you look at the instructions, they give us a coordinate system at the top of the green pin. So what we want to do is we want to put in a coordinate system right there, right? So in order to place this particular coordinate system on our assembly, this is how we go about it. First, we're going to insert a point. We're going to go insert reference geometry point, and then we're going to select the one that says center of face, and we're going to pick right in the middle, and that'll automatically will put the point in the center. Click OK, and then we go back to insert reference geometry coordinate system. That places a new coordinate system like the one that is in here, but we have to line it up to be exactly the way it is in here. So first thing we have to calibrate is the x-axis. So you'll notice the x-axis goes down and to the right along this edge. So we're going to select this edge as the way to line up the x-axis, and you'll see that it does. And then the y-axis goes straight up, which is about the same as this edge. So we'll select that one, and we don't really need to do the z-axis necessarily, but it's the one that's going up and to the right along this edge, more or less, right? So there we go. And you'll notice that we have y going up, x going to the right, and z going to the left, and we click OK. So now we have a coordinate system that looks exactly like the one in the instructions. From here, we can go on to our evaluation, look at mass properties, and see where the center of mass is, right? So you might notice, oh, wait a minute, it still doesn't look like what the choices are here, A, B, and C. But that's because right now we are at a coordinate system from before. Now we're going to click coordinate system 1, which is the one that we put in, and we have x is 342, y is negative 104, and z negative 91. So let's look at which one kind of matches as close as we can. So it looks like here 343 basically is what I have for x. Looks like the first one would kind of match. The second one, y is equal to negative 104, and y here is negative 88, and z negative 91.4. So I have z definitely exact. The y is quite a bit off, so I must have done something wrong with it. But the a is also pretty darn close. So I would say that it is a. But let's look at the answers for number 7. And it says that the answer is indeed A. So one thing that I could do is I can go back and double check my angle mates to make sure that I didn't do anything that I shouldn't have. So the easiest way to check whether we did anything right or wrong is to check our mates. So you notice I have this little guy open where it says mates. And I have my 3 angle mates. So if I click on each one of them, so I click number 3, that was C, and it should be 130 degrees, and it looks like it's 130 degrees, so we are good there. The second one is supposed to be 125, and that also checks out. That's perfect, 125. And let's check. The third one is supposed to be 25. Now we had a different reference point to this, so instead of 25 it was going to be 180 minus 25, which 180 minus 25 is not 150, right? This should be 155, not 150. So if we go ahead and click that, because 155 plus 25 equals 180. So if I change that, okay, and let's triple check on this one. So it looks like it's 155. By the way, if you see this little traffic signal, it means that it might want to rebuild itself. So you click on this guy, rebuild, and off you go. So now we can go back and look at our mass properties and see what it says. So we are going to coordinate system 1, and we check x, 348.66, y is negative 88.48, and z negative 91.4. So it is exact. So that difference of 5 degrees was enough to kind of throw me off, but I was able to easily check it and get the correct answer. All right, so if you have any questions, make sure you ask. Good luck.